Let's go through equals 2,463 minimal total distance traveled. So it gives a list of integer robots which represent those kind of robots' initial um, positions, and also factory. This factory is a two-dimensional array. Every array element in it has two elements. The first is this factory's position, for example, two. And also the second one is its capacity. Means for this factory, it can maintain or repair two robots. So let's try to find the minimal total distance for those robots to have them all of them to repair them. So we'll say the robot can go to any factory, go left or right. But the thing is that we want to find the minimal total cost. For this question, actually, we can think, let's remember one of the question, which is heaters, which we have the heaters and also trying to find a house, right? And they are trying to find the closet, and then we will find the minimal radius. So that is we trying to find the maximum of the minimum. We want to minimize the distance of the minimalist max radius. But for this question, comparing to that is that we want to find a total minimal distance, right? And also the complicated part is that the factory has duplicates, has capacity, right? So it has one more dimension for this. So apparently, this also we have limits is that we need to have all of the robots to be repaired. We should have the total distance to be minimal. So for this question, also because the factory, right, it has capacity. That means those kind of not like the heater that is unlimited, but this one that means we can only put those kind of robots to we try to get it to its closest one, right? But it is possible that this factory is already being occupied by some other robots. So then the robots has to go to the next, right? So apparently, like the Redis, the heater problem, because it's unlimited, we can use a greedy, right? That is the binary search or greedy or two pointer, right? But for this one, apparently, greedy, because it has the limitations, um, greedy may not work because those factories, if we use that, we already occupied, right? So then we may have to try the next. So for this question, actually, what we want is we need use DP, right? So let's thinking about the DP problem. How can we write the initial condition and also the transition functions for this, right? So we'll say for this kind of DPIG, right, that will represent ith factory, this robot, the minimal cost or minimal total distance, right? So in the end, what we want is just a return DP. For example, we have robot, the factory is N, right? Robot is M. That is will be DP N multiplied by N, right? DP N return DP N M, right? So we know this kind of the robots or factories, they have a relationship with the orders, right? So intuitively, what we're thinking about is that we should sort the robots and also we sort the factories first, right? In the in the and then what we want is we're trying to do the DP way. So for this DP, that is ice factory, we need to for example, when we add one more factory, right? When first we need to sort the factory and sort the robot by positions, right? So that because this question has a order related, then what we want is that we want to see if there is one more factory added. So what we can consider is that we have for this factory, right? It has capacity cap. So that means we have the options to um, put from 0 to this cap robots to this factory. Uh, so, for example, originally we have robots from 0 to I, which is put in or to J, let's say J robots put in I's factory, right? Or I minus one's factory. Then we add one more factory when we have I factory. Right now, so what we are going to do is that we have options. We have options to put from 0 to J robots, right? Or we'll see this factory has a capacity I, right? Cap I. We have the options to put min J or cap I robots to new factor, right? So the tricky part is that we are always put um, the higher index robots to a new factory, right? Because the reason is that we are always put robots to factories, right? We can reuse this. So here is something which we can it's provable, right? But the thing that we need to think about is that it will be more efficient that we put the last several robots to a new factory. Then we put the first several one, right? And also when because we want to put all of the factories, robots into factories. So if there is a new factory, what we want is we just try the last several one and trying to see if we are able to minimize the total cost. And of course, we can, the worst case is that we don't use this factory, right? Because it is possible this factory is very far away, even it is new added, and we use the I-1 factory. It's already more efficient, right? But the thing is, if we added that one, we just trying to see if we can get a total distance decreased. Then in the end, right, we try iterate factories and also do for trying to try if we have a new factory, right, trying to test the last, for example, this is C, we have C repair capability. Try the last C whether we can decrease the total distance. And then in the end, we just return DPMM, right? So then we write code for this. we are going to write a two-dimensional DP, and then we are trying to do some optimizations because for this question, two dimension, we can change it to one dimension, just like the rolling hash or uh, 0, 1 backpack problem, right? But the two-dimensional is DP is more intuitive. So let's write two-dimensional DP first. And for this question, um, okay, so as we talk about, we need to sort, right? Collections, sort, robot, and we need to also sort the factories. A, B goes to we sorted them by the positions. Right. Um, let's have int m equals robot dot size and n equals factory dot length. Okay. So let's have long dp equals new long. Let's have n plus one and m plus one. Okay. So initially, we can set this kind of for we'll say dp dp. Let's set this one as large as uh infinity. Okay, private final static long time f equals long dot max value. Let's write shift two. Okay, so arrays fill this one, right? Because we want to have minimal value, right? But since that we know DPI 0 is 0, right? That means we don't have any robots, right? So we need to have for int I equals 0, I smaller than n plus 1, I plus plus. I have DPI 0. Set this one 0, okay? Then let's set use J, okay, because let's use J smaller than M plus one, right? J. Um, we should use I, sorry, I, because J is the second dimension, right? I smaller than N, I plus plus, right? So that means if we don't have robots, right? So the total cost will be 0. J is robot, I is factory. And then what we want is that, for example, we iterate for int I equals 1, I smaller equal to n, right? I plus plus. Then we'll say we'll get the current factory equals factory I minus 1, right? So we know its position equals factory 0, and its capacity equals factory 1, right? So what we do is that we're going to uh, we can write for the robot, right? for the robot, and j equals 1, j is smaller than m plus 1, right? J plus plus. Then we know dpij will at least not be the same as we don't use a new factor, right? I minus 1 j, right? Then we try to put the last either j or minimum of the j or this capacity 1 to the new factors, right? So what we can use int k equals 1, k smaller equal to mass dot min capacity or j, right? K plus plus. So 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 the thing is that we have options, right? We can move. We can have options not to move any robot to the new factory. We can move one. We can move two. We can move until the minimum of the J or C to these new factories, right? So we can add a long cost equals 0. So what we want is that cost should always plus equal to mass dot absolute value P minus robot gate J minus K, right? So every time we move on, we try to update this dpij equals mass dot min dpij and dpi minus 1 j minus 1 plus cost, right? So in the end, we just return dp n m, right? So this will be the code. Just trying to see. N plus 1, INF, J position 0, C, J smaller than this one, long cost, C and G, K plus plus. Cost should, every time we move, we have a new position minus this one, dpij equals return dpmn. Trying to see, not a problem. Serialization long. Let's put this one as capital long. With serialization long. Static long. What's the problem here? Final static long IF equals this one. Collection sort, arrays sort factories. And this is long, right? TP arrays fill. And this is 0 for I smaller than position limit J equals long cost plus cost between dp mn long n plus 1 long maximum value. What's the serialization of long long dp equals n plus 1 plus dp. I think I didn't see any problem here. Let's write this format for int I equals 0, I smaller than n plus 1, I plus plus for j equals 1, j smaller than n plus 1, j plus plus. We have dp I j equals 9f. I don't think this is a problem. Still have this. Which line? At line 94. 94. Smaller. This is factor I minus 1. Limit for j equals dp I minus 1 cos equals 0. Okay. Let's mean this is field anesthetic long. I have this value. Along this one. And dp and m. Didn't see any problems. Compare. Nice. So this is long. I think this should be private final static. Int I small equal to I minus 1. Still, the problem is somewhere with a long. This is 0 plus cost. Actually, this is minus k, right? This is this a problem? Oh yeah. So this is dpi minus k, right? That means we moved k, right? So we transit from j minus k. But I don't know why the arrow, if we use 1, it shows some weird message. It's very confusing, right? So this is two-dimensional approach. But the thing is that we'll see every this kind of I, right? Actually, we'll find that we use a dpij. This kind of I for actually we will find that every dpij will only coming from dpi minus 1 j or I minus 1 j minus k, right? K depend on how many robots we put to the new factories. Well, only coming from up and the left, up left, right? So So what we can think about get rid of the first dimension. This is like the rolling array, right? But the thing is that we can also use to use every time we create a new DP here, right? But the thing is that um, we can reuse just have one dimensional DP with have the m plus one, and for this J, right? We just use a reversed iterations from m to 0, right? So that's this one will always we are going to update, right? Because if we j iterate from left to right, this value will be changed, right? So, but we need left and up values, right? So let's rewrite this one into dimensional DP here. So if we have one-dimensional DP, of course we still need to sort, right? And here, this will be easy. That is, which we don't need to have n plus one. And what we need set the initial value is DP. We can have arrays field DP INF, and DP 0 equals 0, right? And this is the factory. Because we don't iterate the factory, right? We can use I from 0 to n or 1 to n plus 1, both work. But here, what we want is for n, j equals m, j greater equal to 0, j minus minus, right? So we'll have long cost equals to 0, and cost should plus equal to this, and dpj, we don't need to have I, right? And in the end, we just return dpm. So doing like this, we can convert a two-dimensional DP to one-dimensional DP. And let's analyze its complexity, right? So we'll say this one has a sort. So this is m log m, right? This is n log n. But since that this is n, this is m, right? And also well, let's say this is L, the average maximal capacity. So the time complexity will be m multiplied by n multiplied by OL, right? So those are bigger than this sort. So the sort, we can ignore this sort, right? So this will be a time complexity. And the space complexity will be OM, right? We also can write a Python code for this. So we're going to have robot sort. And also we need a factory sort t equals lam x 0. Okay. Then what we want is let's have m and equals length of a robot and length of factory. So we are going to have dp equals float INF multiplied by m plus 1, and dp 0 equals 0. So what we do is for I in range from 1 to n plus 1, we're going to have position limit of capacity, right, equals to factory I minus 1. Okay. Then what we want to do is for J in range M to 0, let's use a reverse order. We're going to have cost equals to 0, right? So every time we try to move, so move K, right? So how many for K in range from 1 to mean capacity or J, right? Um, because we need to add 1, right? Because right is not included. We'll have cost should plus equal to absolute value P minus robot J minus K, right? And also we have dpj equals mean dpj and dpj minus K plus cost. So in the end, we just return dpm. Is thought, robot thought.